Hey everybody, this is what we did in Cal 1 yesterday, Monday, August 16th, 2021. We looked at some of the homework exercises in the text, and here's the first one that we looked at. This is exercise 53 on page 71. And as you know, when we compute a limit, the first thing that we do is we try plugging in the number that x is approaching. So here, we're going to try plugging in 4 for x. And you know what? I wrote down the exercise incorrectly. Please forgive me. This should be a 5 right here. X plus 5 under the radical. Square root of 9 is 3. Minus 3 is 0. 4 minus 4 is 0. And we look at that and we immediately come to the conclusion that this is an invalid result. So we go to our next step, try factoring and canceling. And I look at this thing and I realize that this factor on the bottom is the factor that I want to cancel. And here's why. When I plug in 4 for x, this factor becomes 0. This factor, the only factor in the denominator, is what causes division by 0. So I know I want to cancel this factor in the denominator. The problem is I don't see that factor in the numerator. And I suspect that if I could actually combine these terms in the numerator, that factor of x minus 4 in the numerator would emerge. But I can't combine these factors in the numerator because the radical won't let me combine the x plus 5 with the minus 3. So as long as the radical is in the numerator, I can't go any further. And that's where I say, okay, I have to introduce an auxiliary point. Here's the auxiliary point. Given the radical pair, square root of x plus square root of y, the radical conjugate is square root of x minus square root of y. And similarly, given the radical pair square root of x minus square root of y, the radical conjugate is square root of x plus square root of y. So if we have a radical pair, how do we form the conjugate? We just take the sign that's in between and change the sign. If there's a plus sign in between, we make it a minus sign. If there's a minus sign in between, we make it a plus sign. Well, why am I telling you all of this? I'll tell you why. I told you about radical pairs and their conjugates because of a key property. The product of a radical pair and its conjugate contains no radicals. Well, let's try it. Let's take a radical pair, x plus y, or square root of x plus square root of y, and multiply by its conjugate. And you know what? We've seen this before. We may not think we have, but we have. Let's look at this thing going backwards for a second, going right to left. This is the difference of perfect squares, isn't it? This is square root of x squared minus square root of y squared. How does the square root of x squared minus the square root of y squared factor? Well, suppose this were just a squared minus b squared. How would that factor? Wouldn't it be a plus b times a minus b? That's exactly what it would be, wouldn't it? And that's exactly how square root of x squared minus square root of y squared factors. It's the first thing plus the second thing times the first thing minus the second thing. Now, I just showed you this to justify that this thing is equal to this thing and that we should recognize it because this is the factorization of the difference of perfect squares, and here are the perfect squares. Now, enough of that. I've justified this formula. What I really wrote this formula down for, the reason I really wrote this formula, was to show that when we take a radical pair and multiply it by its conjugate, what we get is an expression that contains no radicals. Square root of x squared, that's x. Square root of y squared, that's y. You see that? This radical pair times its radical conjugate equals x minus y. No radicals here. Now, there is something else that I would like to draw attention to. When we take a radical pair and multiply it by its radical conjugate, and we're trying to figure out exactly what we're supposed to get, notice what we do get. We get the first thing squared, minus the second thing squared. When we take a radical pair and multiply it by its conjugate, we take the first thing, the first term we take the first term of the radical pair and square it, and then subtract the second term of the radical pair squared. So first thing squared minus second thing squared, and the result will contain no radicals. That's important. Now back to our exercise. Here's where we were at. And we realized that x minus 4 is the factor in the bottom that we want to cancel. So x minus 4 is also the factor in the top that we want to cancel. But we don't see it here. We feel pretty certain that if we could combine all the terms in the numerator, we'd get that factor of x minus 4. But the radical here prevents us from combining the terms in the numerator. So this radical's got to go. And here's how we do it. That we take this expression and we take top and bottom and multiply it by the radical conjugate of this pair. And you might be saying, well, wait a minute, that's not a radical. Well, I'll tell you what. Envision this as the square root of 9, and then it is a radical pair, isn't it? So we'll multiply the top and the bottom by the conjugate of that radical pair. In other words, we change the sign in between. And what do we get? Remember what we get? We get the first thing squared minus the second thing squared. And now in the bottom, I could multiply all of this out. I could go 4 times this plus 4 times that, and then I could go, I'm sorry. I could go x times this plus x times that. And then I could go negative 4 times this and negative 4 times that. But I'm not going to do that. Here's why. I already know that this is the factor that I want to cancel from top and bottom. So I want to keep it separate as a distinct factor in the bottom. So I'm not going to multiply the bottom out. This factor right here, I want it to remain isolated from this factor. So I'll just take my x minus 4 and keep it separate. And I'll take this factor, square root of x plus 5 plus 3, and I'll keep that separate. And what do we have? Oops. This is just x plus 5 minus 9. Don't forget to square this thing. Minus 9 all over this garbage. Okay, x, 5 minus 9, negative 4. Aha, there's that factor. There's that factor that we wanted to cancel. Here it is. And we go zip, zip. Well, what do I do now? Didn't I just cancel the zero factor from top and bottom? We just got rid of all the troublemakers. So what do we do when we cancel out the offending factor from top and bottom? When we've gotten rid of all the troublemakers? Yep, now we plug in. There we have it. Now, I made this pitch in class yesterday. I probably made it in the first video that we had to watch as well. What I said in class was we are definitely going to have an exercise like this on test one. Going back to the year 1982, I have always had an exercise of this type. Where we had to multiply by the radical conjugate and simplify. I have always had an exercise like this on test one. And when you go to my website, you look at the practice tests, you're going to find out that yes, every test one, going back decades, has an exercise like this. I'm telling you this so that we can make full and proper use of this information. We know we're going to have something like this on the test. Now is the time to learn how to do exercises like this. Practice this. You might even want to go to my website and look at some of the test ones from previous years and work the exercises that are like this. This is how we get 100 on our tests. We know the different types of exercises that are going to be on the test, and we learn how to do each one. And for each exercise like this that we learn how to do, that's 10 points in the bank toward a 100 on our test. So we know it's going to be on the test, and I make sure that we know it's going to be on the test. We learn how to do everything that we're going to be asked to do on the test. And each time we learn something that we're going to be asked to do on the test, that's 10 points in the bank toward a 100. This is how we get 100s on our test. And oftentimes I see quite a few hundreds on my test, and that's what I want to see. And I want to see it from you. This is how you do it. I have more to cover from yesterday. I'll have to do it in a separate video. I'm going to have to give this classroom up for a class that's coming in right now. But I will send you another video in a couple of hours.